So this is the first lesson of chapter 2. This is 2.1, the equation of a line and midpoint formula. So we really need to understand, we need to remember what slope is before we can do these equations for midpoint. So we're going to review what the slope is. Hopefully this will be all familiar to you guys from grade 9, and then we're going to move on to midpoint. Okay, so our goal for this lesson is to review how to determine the equation for a line given point and slope, or 2 points, to learn how to determine the coordinate of a midpoint of a line segment. Okay, so remember, slope is rise over run, and our slope formula is y2 minus y1 over x2 minus x1. Okay, where x1, y1, and x2, y2 are any 2 points on a line. Rise refers to the up-down direction, and run refers to the left-right direction. That is not what I wanted. It's kind of the same thing, but I need to record this, so I want to show you this. Okay, we'll keep going. That should pop up. All right. So example 1. What is the slope of the line segment between A and B? Whereas A is 2, 4 and B is 6, 12. So who can tell me how to figure this out? Just trying to get rid of the graphics here. I'll just leave it. Who can tell me how to get the slope of this line? Yeah, Ethan.
Over x2 minus x1.
Okay, so we get y2 over here. Okay, our slope is 2. Example 2, what's the slope of the line segment between these 2 points? RC. What's the slope of this? Okay. What's this? Negative 3 minus 7. What's that? Sorry? Negative 3 plus 7. Positive 4. And then negative 3 plus 3. Negative 1, right? Yeah? Negative 4. Okay, so those are our 2 slopes. That's review. Okay. The equation of a line can be expressed in different ways. We know we can express it y equals mx plus b. That one you're familiar with. That's called the slope y-intercept form, where m is the slope and b is the y-intercept. The standard form now, I don't know if you're familiar with this or not, but basically you can rearrange this equation to be represented as ax plus by plus c, where a, b, and c are integers and a and b are not both 0. So basically you can take this formula, rearrange it to look like this, and that's called standard form. Any questions there?
Sure.
Yep.
C would be the y.
C would be the y-intercept, correct, but it would be on the same side as the x and as the y. So it would have a different sign than it does in this format. So you wouldn't really consider it the y-intercept because it'll be confusing. You wouldn't get the y-intercept from this formula. You would rearrange it like this if you wanted the y-intercept. Okay? It would also only be the y-intercept if this was y and not like 2y as an example. Do you see how that would get confusing?
Yeah.
So you can't take C as the y-intercept because it's not. All right. Okay, example 3. Find an equation for the line that has slope -7 and y-intercept 11. Andrew.
Y equals M7 plus 11.
No. I like the plus 11.
X plus 11?
Yeah, that's right. -7, because that's m. So -7x plus 11. Make sense? All right. Standard form. Ethan? Yeah?
7x plus 1y plus 11.
No, not plus 11. It would be minus 11, right? Because the 11 is coming over the equal sign. All right? Any question there? Yeah. Why is it positive? Because it's moving over the equal sign here. We're taking away, we're adding plus 7x to both sides. So this cancels and we have plus 7 on the left of the equals. Do you see that? Make sense? Okay. All right. Example 4. Find an equation for the line that is parallel to this line and passes through this point in both slope y-intercept and standard form. So we're going to find it first in slope y-intercept and then in standard form, which makes sense because we can just rearrange this. So what does that tell us if we know a line is parallel to this line? What does that tell us? When two lines are parallel, Jafet?
The same slope?
Yeah, when two lines are parallel, their slopes are the same, right? Whether they're like this, their slopes are going to be the same, or like this, their slopes are the same, right? So we know then the slope for this line we're trying to find is what, Milkias?
Minus 2.
-2, excellent. Okay, so we have -2, and we know it passes through 1, -3. So what we actually have here is y equals -2x plus b. Now we don't have b, but we know it passes through 1, -3. So Josiah, what can we do to find b?
Sorry, pardon me?
We need to find b. What can we do if we know that the line passes through this point, 1, -3? What can we do to find b? Sorry? Yeah, exactly. We're going to take that point and we're going to substitute it in. Okay, so what am I going to put in for y? Josiah? Yep. Equals -2 what? 1 plus b. Okay? Now I'm going to solve for b here. So I get -3. The 2 comes over. Plus 2. We get -1 is equal to b. Alright? So then our equation for the line becomes, Douglas?
Y equals -2x plus -1.
Yeah, but I wouldn't write plus -1. I would write
Minus
-1. Alright. So that is our equation for the line in y-intercept slope form, or slope y-intercept form. Now we want to go to standard form. So how can I get to standard form? Teodi. Substitute what? The difference between slope form and standard form is just like rearranging. Okay, you don't have to do any substitution, elimination. You're just rearranging. So what can I do here? How would I write standard form? What's my x value going to be up here? So if I'm moving the 2 to the other side, I get what? Yeah, I get positive 2x. And now plus what? Yeah, plus y. Good. And now I get my C value, so I got to move this -1 to the other side, so it's going to be plus or minus? +1, yeah. Make sense? Any questions? That's it. Okay. Next. Yeah.
Can you only get the standard form by first getting the slope y-intercept form?
Yeah. Right now. Definitely. Because we only know certain pieces of information. It's given, right? We know the y-intercept was given, the slope, and so it makes more sense to get this form first and then convert to standard form. Okay? So the answer is yes to your question. All right. Example 5. It says, find an equation for the line that passes through the points -1, -3, and 5, 6. Okay? We need the slope y-intercept form. And it says here, it tells us what to do here. It says determine a slope. So, why not put on? Stefan, how do I get the slope of this line if it passes through these 2 points? What's the slope?
M equals
y2 minus, okay, over,
x minus y1.
no, x2 minus, not y1, but x1. Okay. Alan, keep going. What's the y2 and what's y1? No, this is point 2, right?
6 minus -3.
Yep.
And 5 minus
Okay. Keep going. What's that, Alan?
that is positive 9 over positive 6.
Good. Which is? No, what's 9 divided by 3?
3.
Yeah. And what's 6 divided by 3? 2. Okay, good. So that's our slope. So what is our equation then? So far. Y equals, Alan?
3 over 2
Yeah, what?
x
Yep.
plus
Do we know B yet? No, we don't know B. So how can we figure out B, Liam? Say it again? Plugging what in? You're right, we gotta plug something in, but what? Yeah, which one? Does it matter if they're both on the line? So which one we're gonna pick? This one? Because we want to stay away from the negatives. Is that the reason? Okay, let's do it. So we're gonna say y is what then? Okay, 6 equals 3 over 2. What's x? Okay, plus b. When we're trying to find b here, so we're gonna get 6. 3 times 5 is 15, so we have 15 over 2 plus b. Okay. Now to get rid of this fraction, I can multiply everything by 2, so I'll get 12 equals 15 plus 2b. Let's go take it up here. Now we're going to have 12 minus 15 is minus 3 equals 2b. b is equal to negative 3 over 2. Okay? Any questions there? All right, so our formula is what then, Andrew? Y equals?
Y equals 3 over 2x minus 3 over 2.
Nice. Beautiful. There's our equation in slope y-intercept form. Ethan, yeah?
1 over the 1
When do we change it to a decimal fraction?
You could do it right now if you want.
Is it
Bo-
just like with the original?
Both are correct. Okay, both are fine. I don't really mind. I find fractions easier to work with. If I don't have a calculator on me, they're much easier to work with. But if you do have a calculator, you can go directly to fractions. Okay, so now I'm going to do what? Jaden, what's the next step? How do we get to standard form? Say it again, louder. 3 over 2x. Okay. Plus y. Okay. Now, is this going to be positive 3 over 2x or negative? Negative, right? Because it moves over the equal sign. You see that? Okay, so we're going to have negative here. Plus y. I like it. Now what? Yes. Plus. Yes. Equals. Good job. Excellent, Jaden. Okay, that's our standard form. Pretty simple. Now, if we didn't want these fractions, if we don't like the way that looks, we can multiply everything by 2, right? Because the common denominator here is 2. We would get negative 3x plus 2y plus 3 equals 0. And actually, yeah, that works. And that's what we should do, right? Because in reality, it's asking for standard form like this, where a, b, and c are integers. That's by definition. So you don't want them to be fractions. So you would have to multiply this by 2. Okay, any questions there? All right. Yeah? We multiplied by 2 to get rid of the fractions. See these two fractions? Okay, everyone understands why the multiplying by 2 got rid of these? Yeah?
So would negative 1.5x plus y plus 1.5 be acceptable too?
No, because it wants these as whole integers.
So there has to be a number for that.
Yeah, so you would have had to multiply it by 2. Okay? Part 2. All right, so now that was review of slope. Now we can do the midpoint formula.
Wait, so
Yep.
in the other question, we left the y with no integer. Is that acceptable too?
Left the y with what?
We left the y with no number in front of it. Is that like acceptable too?
We're talking about this question?
Yeah.
Yeah, it's a 1. You just don't write
Oh,
it.
it's a one.
Yeah. Whenever there's no number, it's a 1. All right. Part 2, midpoint formula. So a midpoint of a line segment is the point of that line that divides the segment into 2 congruent segments. Congruent is just a fancy word for equal, 2 equal segments. All right? So our investigation, we're going to use a Cartesian plane to plot the line segment defined by each pair of endpoints. We'll label the endpoints with their coordinates and then determine the coordinates of the midpoint of each line. All right, so here, let's do this. A is negative 5, 7, so we're going to go negative 5, and then we're going to go plus 7. This is A. Then B is 9, 7. Okay. So there's our line. Okay, now just like in the video we watched, how can we get the middle of this point? Well, we can count all count the grid. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. And then we can go right in the middle of that, so we would go 7, right? 1, 2, 3, 4, 5, 6, 7. So we know this is the midpoint. Okay, next one, C is 1, 1, 1, 1. C, 1, 1. D is 7, 5. D. Here's our line. Okay. C is, so now to get the middle of this point, okay, if we watch the video, we count our run, 1, 2, 3, 4, 5, 6, so we get the middle, 1, 2, 3, there's our middle. The rise, 1, 2, 3, 4, we get the middle, 1, 2, and then where those 2 points meet, the line, that's our midpoint. Okay, so this here is our midpoint, and that would be 4, 3. And this midpoint up here is 2, 7. Okay, last one, P and R. So P is -5, -4, and P -5, -4, and R is -1, 0. Okay, we're going to draw our triangle again. 1, 2, 3, 4. 1, 2. 1, 2, 3, 4. 1, 2. Here's our midpoint. And it is -3, -2. Any questions how I found all those midpoints? Now that's all fine and dandy if we have a Cartesian plane, but I don't know if you guys are like me, I hate graphing. It's not fun, it takes a lot of work, it takes a lot of artistic measure to draw them nice and neat, a lot of patience. So we're going to try and find it algebraically. So it says, in analytic geometry, there are at least 2 ways to determine the midslope of a line segment. So the first method, we're going to calculate the rise and run. So let's do that. So it says the city has 2 hospitals shown on the map of the coordinates, this and this. The city wants to build a new ambulance station halfway between the 2 hospitals. So it wants a midpoint. Determine the coordinates of this location. So basically it's asking us to determine the coordinates of the midpoint, right, of the hospital. All right, so first we'll find the rise, and then we'll find the run. So let's do rise is y2 minus y1, which is going to take these values here. So 14 minus 5 is 9, and the run x2 minus x1. So it's 11 here, minus 3. So we have the run of 8 and the rise of 9. Okay, so now our midpoint then of AB, just like we did with the other graph, but we're going to do it algebraically now, is you're going to take the first x value, so this x value, and we're going to add half of the run. So just like we did over here, we take that point, we add half of the run. Okay, we're going to do that, but we're going to do it algebraically. So we're going to add, the run is 8, so we're going to add 8 divided by 2. And then for the y coordinate, we'll take the y1 value, which is 5 here, and we're going to add half of the rise. So y1 plus the rise over 2. Any questions what I'm doing? Anyone's like, what the heck did he do? I'm just basically putting a formula to this, right? What we did before. You got your x1 and y1 point, and you're adding half of the run, the total run, and you're adding half of the total y to get to this point. Does it make sense? All right. So there's our formula. So now we can just substitute in our first x value here, which is 3. And then our first y value, which is here, which is 5. Okay, and if I find a common denominator here so I can add these fractions, I would actually have 6 over 2 plus 8 over 2. And then I would have 10 over 2 plus 9 over 2. So I would have 14 over 2 and 19 over 2. Right? So we get 7 and 9.5. All right, so that's the midpoint. That should be the hospital location. So let's check it out. Let's see if I'm right here. So we're going to go to 7, and then we're going to go up 9. We're going to go up a half. Right there. There's our midpoint of AB. And it is 7, 9.5. Any questions there? Okay, so the mid. This.
Yeah, that.
Yep. Okay, at the bottom here, I'm gonna get rid of these graphics. I don't know why they're there. They shouldn't be there when I upload the video. The midpoint of a line segment can be found by adding half of the run and half of the rise to the coordinates of the first endpoint. Okay. So our method 2 here, we can just use a straight formula. So we don't actually find the rise or the run first. We just actually find them inside our formula right here. This is as we know the rise. This is as we know the run. And when we divide something by 2, we're cutting it in half. So our formula for our midpoint works out to be x1 plus x2 over 2 and y1 plus y2 over 2. And it works for all line segments, vertical, horizontal, or diagonal. Any questions about the formula? Now you guys know where the formula came from. Let's try and use it. Okay. Find the midpoint of the line segment AB. So here the work is done for us. Here we have A and B, so we have our x1, y1, x2, y2. Plug that into our formula. Here's our x1, here's our y1. We add, we add x1 plus y2, x2, and we divide by 2. So we get this, negative 3 plus 2 divided by 2. And then y2 plus y1 divided by 2. And we get this for our midpoint. Okay, so it's very similar to the slope calculation. You're just adding the addition of a starting point, right? So don't be surprised if your answer contains a fraction. Answers may be left in fractional or written as decimals. As I said, you can do either or. Okay, but here's our example. Determine the coordinate of the midpoint of a line segment AB with the ends at A, negative 7. This example here was for this. So negative 0.5 and 2.5 is right here. So this is our midpoint. Okay, that's this example. Now example 6 is going to be down here. Okay, so what is the formula for midpoint AB? Now, who can tell me that? Everyone's hand should shoot up, right? Because that's what we've been learning the whole lesson. Just Andrew knows. Josiah, can you take a guess here? What's the formula going to be for midpoint? Sorry? X1. Good. So X1 plus x2 divided by
Oh, 2.
2. Good. And then the y coordinate?
Y1 plus y2 divided by 2.
Excellent. Very good, Josiah. Okay, so we now, can we use substitute, keep going, Josiah? What am I going to put in for x1?
7,
-7, yeah.
then 3
Plus
plus
3,
3,
yeah.
and then 11
Yep,
plus
yep,
23.
yep. Good. Okay, keep going. Let's go up here. Keep going, Josiah. So -7 plus 3 is?
-4.
Good. Yeah, and then 11 plus 23? Excellent. -4 divided by 2. Yep. And 34 divided by 2.
17.
Yeah. Okay, so therefore, the midpoint of AB is equal to -2, 17. Any questions? No questions? All right, last example. Here we go. We're actually going to finish with some time to do work. Great. Example 7. The midpoint of the line segment CD is, oh, this one's giving us the midpoint. Well, it's going to be tricky. So we have the midpoint. Determine the coordinates of the point C if the coordinates of the point D are -2, 12. Okay, so we want to know C. And we know D. And we know the midpoint of CD is that. Who can tell me what to do here? A little harder.
Standard form.
Hmm?
Did you put it in standard form?
Nope. You wouldn't be worried about the equation for the line. You're just worried about midpoint. So let me write a few things down here and see if this will help. Right? That's our formula for midpoint. Right? But we know the midpoint CD. So it's actually 7 -11 equals, and we actually know this is point 2, right? So we know x2 and y2. So we can fill this out. Does that make sense? You guys with me there? What would be the next step?